Ashna.
Hi, my name is Anya.
Hello, my name is Anya. Hi, I'm Tashina.
Hi, my name is Shinta Mia. Hi, my name is Almas.
And I'm Anisha.
This is an overview on the reason why we made our project. In Malaysia, it is fairly common to see residents hanging their wet clothes on a drying rack, whether indoor or outdoor. Yet, those clothes will surely be exposed to polluted air. Hanging wet clothes indoors will raise the humidity of the room by 30% or more, making it an ideal environment for mold.
Moreover, people that live in high residential areas and don't own an electric dryer don't have enough space to dry their clothes, as they would have to dry their wet clothes outside on the railing, making the clothes quality more pale.
Now, I will focus on the background of our project. Traditionally, we dry certain things by laying them under the sun, but this method seems to be easily affected by the weather conditions. Plus, we wouldn't be able to dry anything if it is raining, as the process of evaporation can be done. Other than that, using an electric dryer would cause an increase in electricity consumption and the production of CO2. And so, we propose a dryer that uses PV solar technology to generate electrical energy, eliminating the need for fossil fuels and avoiding energy waste. This solar generated energy is used to heat a large volume of air, which is then directed to flow over the product. This hot airflow removes moisture.
The objective of these innovations is to reduce electrical consumptions and productions of CO2. So by reduced electrical consumptions, we can reduce electric bill too.
This is the solar dryer. Its structure is built using PVC pipe. A tablecloth is then used as the cover due to its waterproof feature. A zip is then sewn on the front, and a layer of net is placed in front of the fence to prevent any insects or big dust from entering. To hang the clothes, one pipe is filled with cement. Plywood is drilled onto wheels to make it more portable. The solar panels are connected to extension wires which correlates to a solar controller, then connected to a rechargeable battery. There are two sets of fans where one moves air in while the other moves air out of the dryer. The wires are then linked to the Smart Socket app which controls the inverter.
An auto photodetector on the solar panels which allows the solar panel to move automatically following the position of the sun. This is to detect the sunlight better.
For experiment result, here we have done 3 experiments. We have 2 testing procedure and a survey procedure. For testing procedure 1, we prepared 1 piece of clothes and dried it by using both method, which is the conventional method and also in solar dryer each. Then we record the time taken for each clothes to dry, and we repeat all the steps by increasing 1 piece of cloth each time. We conducted an experiment where we put 5 pieces of clothes in the solar dryer, adding 5 more pieces until it reaches its maximum value to test the time taken for each clothes to dry. It shows that 30 pieces of clothes can dry in 6 hours and 15 minutes. In conclusion, the maximum amount of clothes that can be dried is 30 plus minus 5. And the maximum hours of clothes to be dried is 6 plus minus 1.
For testing procedure 2, we compared a cloth sample dried using solar dryer and another sample dried using the conventional method. A sterile swab was used to collect bacteria from each sample, which was then applied to agar gel in a petri dish. The dishes were sealed and stored away from direct sunlight for 5 days. After this period, Table 2.1 and Table 2.2 showed that clothes dried by the conventional method contained dust and bacteria, whereas there was no visible difference for clothes dried using the solar dryer. This indicates that the solar dryer helps reduce dust and bacterial contamination during drying. We also conducted a survey to gather feedback on the solar dryer's properties. For question 1, 52.9% agreed and 44.1% strongly agreed. Meanwhile, for question 2, 25.9% agreed and 32.4% strongly agreed. These results reflect a positive perception of the solar dryer's effectiveness.
The first one is our marketing strategy. This solar dryer's current price is 1,000 ringgit with a 2% of profit, but can be reduced to 600 ringgit with a 22% of profit once done small or better than our current prototype.
The estimation selling price for mass production is lower than our current price due to several factors. The raw materials needed can be obtained for a lower price, which is estimated to be about half of its price if it is purchased as wholesale. Other than that, having professionals to build the products may reduce the reliability towards ready-made products, which can reduce the cost. And lastly, a consideration towards labour charges for mass production needs to be made. Therefore, the selling price for mass production stated is just an estimation of all the overall factors highlighted. Next, target customers. We target people that live in high residential areas. This is because they don't have to worry about being taxed while drying their clothes. Other than that, we also target college students. This is because they have a lot of necessities to spend on, such as their accommodation and groceries. They don't have a stable income, so an electrical dryer will not be suitable for them. Other than that, one of our main target customers are low-income families. This is because they can't afford an electrical dryer. So, a solar-powered solar dryer is perfect for them as it can reduce the electricity bill. Lastly, for selling action, we plan on finding companies to collaborate with to sell solar dryer. Some companies we had in mind were Media, Toshiba and Solar West Malaysia. We chose Media and Toshiba because it is well known for their electrical appliances, especially their electrical dryers. So, if we collaborate with them, maybe they can help us to upgrade our product and people will actually buy our solar dryer. We chose Solar West Malaysia because it is the greatest solar company in Malaysia. We think that all these companies can help our project grow and also advertise them.
From this, we can conclude that solar dryer is able to reduce the emission of carbon dioxide and protects clothes from being exposed to dust and polluted air.